thanks for being patient. I've also got a couple of, you can see my laptop stand here is pretty advanced. Quick personal intro for me. My name is Paul Jolly. I used to be a co-organizer of London Gophers a few years ago. It's fantastic to see Bruno, Ben, and others keep it going. And thanks everybody for coming along this evening. It's good, sort of post-pandemic, to actually see people in person. So thanks for coming along. I now work full-time on the Q project, and the Twitter handle is down at the bottom right there, and the website is bottom left. And my personal Twitter handle is on there as well. What I'm going to be talking to you about today is how Go and Q can be used together to make what I consider a sort of a match made in heaven. We'll explore that a bit more. So what are we doing today? I've got to move both sets of slides forward here. As was advertised on the meetup page, I'm going to be giving a live demo showing how a Go program can be that already consumes a JSON configuration can be adapted to use Q instead. We'll also talk about why you would do that. Why is JSON perhaps not the best tool for the job in this situation, and why is Q better? As it says, Q is an exciting new configuration, data, and validation language, and we'll explore a bit of what that actually means as well. This presentation promises to be exciting in more ways than one because there is a live demo. So that can potentially go very, very wrong. So please bear with me if it does go wrong. So the program I'm going to show you in a minute, what does it actually do right now? Well, the answer is not very much. It's based on Gophers, which is a lightweight supervisor D, which allows you in a local setting to actually start, run, and pull down. Okay, trying again. So what does our program do? It's inspired by Gophers, as I said, which is a lightweight supervisor D, which is basically a program that is responsible for keeping a set of programs that you would like up and running. And if they die, it will restart them. And that sort of program needs to be configured in a certain way. First of all, you need to say, well, what programs do you actually want to be up and running? Maybe there are then certain environment parameters or flags that you want to pass to those programs. So there's quite a decent amount of configuration that actually ends up being required there. So this is a good example to use as the basis for our demo today. So let's have a quick look at this demo. Now you need to tell me whether you can see this. Can everybody see this okay? At the back, perfect. So, let me just check that you are. Great. So, if we have a look at config.json, we're going to take a look at let's just go, is that still visible for those at the back? Yep. Just so we can fit, the JSON is a bit expansive in terms of. So here we can see the configuration for our program. There's a top level programs field here. And beneath that, we have what is essentially a map, which is from the program or service name to the configuration for that program. So you can see for service one, we're saying, well, the thing you're going to run is that the binary is in path to service one. We've given a nice description there. We've said what args will be passed to service one when Gophers tries to run it. We've specified what the working directory of service one should be as well. And we're saying we should actually ignore errors. I don't actually know what that means in the context of Gophers, but let's just go with it. It sounds like a good thing to do to ignore errors. Don't quote me on that. Service 2, similarly, so you can sort of see how this goes, right? We're building up a big map here of the programs that we want Gophers to be responsible for maintaining for us, ensuring they're up and running, and if they die, for it to restart them. So this is pretty straightforward here. So let's have a look at what our program does, and this is where you're all going to be very, very disappointed. So let's just scroll down a tiny bit here. So this is just a very simple Go program. The main function, as you can see here, first of all, we establish where is our config file. And here I'm using like a fake home, not my real home. So for the purposes of demonstration, it's easier if I have a home directory within my current directory. So that's what's going on here. And so you can see we're establishing a file path to the config file, and that at the moment is config.json within this directory path here. So we read that file, and then we use a variable that is of type config here, and you can see this now reflects that configuration structure that we just saw in the JSON file. So here's that top level programs field, and then that's a map of string, and the string is the name of the program in this situation, to something of type program, and that's where we have path, args, description, etc. So you can see how the JSON file that we looked at is now going to be handled by the Go program here. So once we've read this file, all we then do is we declare ourselves a variable of type config, and then we use JSON unmarshal to say, okay, load that JSON and unmarshal it into this variable here. And JSON unmarshal does all the wizardries there of it then populating all the relevant fields and creating new instances as required of program as it goes through. So then all we do at the end there is we use key3rx pretty package to actually print this out so we sort of see it in a fairly nice way. So let's just see what this does now. Not very exciting, because it looks very, very similar to the JSON that we have actually consumed. So you can see our program does nothing at all other than load a configuration and then print it out for us. But hopefully you can see the kind of the detail of what it actually would do doesn't really matter for the purpose of this talk. We're just talking about how instead of loading from JSON, you can actually load from Q and make your configurations more maintainable. And just check that I've said everything I should do. One thing worth pointing out is that we're doing a talk today that talks about how a program that's configured by JSON can be configured to instead be configured by Q. The same could apply for YAML, because Q, as I'll explain later on, understands JSON, YAML, and lots of different data formats, as well as different schema formats as well. So everything where I say the word JSON today, you could equally apply YAML as well. So now let's actually convert this program to using Q instead of JSON. So where do we start with that? Well, first of all, let's just clear the screen here. I've got the Q command line tool installed here. And so Q is a number of things. And one thing I'm showing you now is the command line tool, and that allows you to do a number of things. If I just do Q help, it says there are lots of different commands available for Q, and we're just going to use one of those now, which is Q import. So what I can do is I can say Q import, and then give it the path, to our JSON file. And what that's then going to do is create a Q version of that JSON file. So let's take a look and see what that looks like. So this looks kind of similar to JSON. And that's sort of intentional because Q is actually a superset of JSON. So let's point out some of the similarities and differences between the two. So one of the first things you'll notice is that the field names themselves don't actually have to have quotes around them, which is a nice thing. That saves us a few keystrokes of not having to actually type quotes for field names, unless there is actual spaces within them. We don't have to have commas. You can see there's no commas at all here, unlike JSON. And so the rule there follows something very similar to Go's rule for semicolons. You don't need to type semicolons in Go. It can actually infer where the semicolons should be. You'll see that here, for example, we have multi-line strings. And these are very Swift-like in their style. And so that's a very nice thing. Instead of having to do \n and worrying about all your escaping, using backslashes, etc., you can just create yourself a multi-line string. Unlike YAML, strings always look like strings. So the right-hand side, like the value for a field, is always quoted. So you can see for all of these string values here, here's a list of strings here. Each one of them is quoted. Unlike YAML, where if it was just a string field, string value, for example, you would be able to elide, i.e. leave out those quotes. Q is not white space sensitive, unlike YAML, and that makes writing Q quite a bit nicer. And there's now a nice little demo I'm going to show you here. So if I just trash the formatting in my Q file here, i.e. I've just shifted it all left, whichever way you're looking at the screen, and now I'm just going to save that file. And qfont works like gofont in then formatting that automatically for you. So you've got very good tooling within the editor for actually ensuring that you have consistent looking Q. And like Go, that just means that there are no more arguments about how should this Q be formatted, just like Go as well. So this is good. So that Q looks pretty good. Now let's actually get rid of the JSON file. So we don't need that anymore. And what we can do is now show you the second command here, which is qexport. And we can then say, well, show me what, and JSON is the default export format for Q. What does that actually look like? Well, this looks identical to the JSON file that we just deleted in this situation. So Q is able to do this two-way translation between JSON and YAML in the data capacity, and it has that similar capacity in a schema language as well. And we'll talk about what Q schemas are in just a second. So this is great. We've got ourselves, let's just clear this here. We've got ourselves our Q file here. So now actually, let's start using this Q file. We've deleted the JSON file. Let's make a change to our Go program to actually use it, to use that Q file. So first of all, let's make this change here. And so we're going to load the Q file. And now what we're actually going to do is use an experimental package that we're showing for the first time today, qexp qconfig. And down here, we don't need to read that file anymore. I'm just going to make this change, and then I'll explain it a bit more. Qconfig load. We just need 3 nils there for now. And then just run go more tidy here. Hopefully I'm still connected to the Wi-Fi, otherwise it shouldn't be a problem. Oh dear. That does not look good. 1 second. We have to improvise here. Give me 1 second, and we'll fix this up. Great. Took advantage of the fact that I already had it cached. So now let's just go back here, and this should be good. Ah, there we go. So now all we've done is we just need to specify the path to the Q file that we're actually trying to load here. And now we use this single entry point in the qconfig package, which is load. But basically says, well, give me a file path or a directory where I can find some Q to load. We'll come to these parameters later on. And much like the JSON Marshall, you just tell it, well, where do you want to put the result? So now let's give this a try. Great. That looks identical if you quickly skim it to what we had before. So we've already now, where are we now? We've already switched from using JSON as our configuration file format to Q. And you actually see that the Go program itself is slightly shorter. But is that it? That's not the end of my talk. qconfig is designed to actually, and as I said, it's an experimental package. It's designed for Go programmers who are writing tools like this, command line tools, to provide an easy way of loading Q configuration into your program and then using that. But it's not just about, Q is not just about loading it in the same way as JSON, it's also about validating as well. So let's also take a look at that a bit as well. Good, we're done with that one there. So as I said, another aspect of Q is this idea that it can perform validation as well. So the Q that we see here is just data. Just like JSON, there's no schema. So if anybody has used JSON schema before, JSON schema and other schema languages allow you to describe effectively the shape or the model of the data that you're looking at, and then use that schema to validate some data. So that's a fairly common pattern, is that we don't just write configuration files and hope for the best when we load it into a system. Ideally, we want to try and validate those configuration files ahead of time, so that when we come to use it in production, we know there are actually sensible values in there, that we have strings where we're expecting strings and the same things like integers, etc. So Q is great in that respect. You can not only represent data, you can also represent schema as well. So now let's actually do that. Let's just go back to main. Okay, and what are we going to do is create ourselves a schema Q file. And Q, we'll gloss over this for now, but Q has the concept of packages much like Go. And we'll just put it in a package called main because that's where our Go program is for now. So what we're trying to do now in Q is describe the shape of data we're trying to validate. So as we saw before, we have this programs field. And beneath that programs field, we've got sort of an arbitrary map from the name of the program we're trying to configure to the configuration for that program. And so in Q, what we can do is we can express that using a pattern constraint, which basically means, well, there can be, this is effectively me declaring a map here. And then what we're going to say is that we're going to use a definition to define the shape of a program's configuration here. So this basically says that when you see the programs field, any field beneath it is what we know as the name of that program. And then what the right-hand side there must satisfy is this definition here. So let's just take a look straight away at what that should look like. And again, you can sort of see this is fairly JSON-like in the way we're declaring things. But now we're in sort of schema world. We're not doing actual data values, we're doing types here, describing the shape or the model of this data. So one of the things we want to do is, you remember, we had a path field, that's of type string. Args, well, they're optional. So there's the question mark coming in there, and that is a list of strings. Description, we have one of those, and that was of type string as well. One thing we didn't see, but we'll come to later on, is this concept of retries. Imagine our Gophers program here. If it just keeps on having to try and restart something because it keeps failing, we clearly don't want it to keep on trying forever. So how many times should it retry? That's what this retries configuration is going to tell us. We saw ignore errors. That's an optional field as well, and that's a type bool. So you can see this is how, I'm not writing data here, I'm writing what is much more like a Go type. But this is what we call the schema side of Q. And so if it looks like JSON because of the way it's structured and the fields, etc., then that's intentional. If it looks like Go, that's semi-intentional as well, because you can sort of see it exists between the pure data of JSON, but also the types of Go as well. And then we optionally had as well, I type that directory, yes, a directory field where I have done something incorrect here. Can anybody spot my error? Why is it not happening? Oh, it's just a very long line. That's a very annoying thing. Thank you. So here is our schema. This is great. So I've just written this in a separate Q file here. And notice where I've actually written. The schema file is in the root. Let's just clear this here. Alongside the Go program that we have here. So basically I'm saying this schema belongs to the Go program, and the Go program is going to use this schema to actually validate configuration that it loads. So now let's actually flip back to the main.go file here, and we want to use this schema. So let's just scroll down a tiny bit here. And this is where we're actually going to use embed. Now, if people haven't seen this, I'm not going to, I'll just briefly talk about it. What it allows us to do, let's just quickly declare it here. And I'm going to say schema, I'm going to say that's a type byte. I need to then say schema.q. I'm sorry? Thank you, that's a very good spot. Let's fix that. Someone's paying attention, that's very good. So then let me just make the change here. And oh, that's a bug in my current version of Go, please. So there we go, it's happy now. So all we've done here is we've declared a variable schema of type slice of bytes, and Go embed basically allows you to say, well, this file here, schema.q, I want you to load that as part of the building of the Go program and put the value into this variable schema here. It's an incredibly powerful thing. If people haven't seen it, I strongly suggest you take a look at it. It's very, very powerful when you need to ship a binary with the contents of some other file. And in this situation, you can see we're using it to load and carry around with the program the schema that we've just declared, which is exactly what we want to do. We don't want to have to carry around the schema file with us as well. We just want it embedded as part of the Go program. So that's great. So that means we could just build our Go program and ship that around and deploy it to places and use it places. And schema.q is embedded within the Go program, which is exactly what we want. So you can see the other change we made here was to use that schema variable here in the second argument to load. So let's see what this actually does. Hopefully nothing. Great. This is not very exciting on the basis that our Q was already valid, and the schema says, yes, it's valid, so there's no problem here. So let's break it. Config.q. And what definitions allow you to do is they say, well, these are the fields that are valid for a program in this situation, but they also allow you to say that no other fields are valid. So if I add a field here, blah, and put rubbish in there, for example. According to the schema that we declared, let's just go back to here. The field blah does not exist within that schema there. And because this is a definition, and that means it's closed, it means you can't just add random other fields to it. So now we should expect it to actually throw an error for us. So let's just go run. Sure enough, as you can see down the bottom here, it says field not allowed blah. It tells us exactly where that error has occurred as well. And in the config file, it's on line 11. Let's just jump back to that. Sure enough, line 11 there. So now we've done nothing other than actually declare the schema that describes the config that we've loaded in this situation. You can see the qconfig load has got a very easy way of saying, well, here is the schema that you need to apply to validate things. And we've just changed a couple of files and validated that it actually works by breaking the configuration. So let's fix it. Confirm that we have fixed it. Great. So now we're back on safe ground here. Now let's spend a bit of time looking at our configuration here, because there are a number of things that aren't really ideal about this. There's quite a lot of redundancy going on. First of all, let's take a look at the path field. There's a sort of a pattern that exists here, right? For each of these, path is /path2, and then the service name, or the name of the program, service 1, 2, or 3 in this situation. So maybe we can actually do something there. And Q, this is where Q comes into its own. It's not just pure data, and it's not just pure schema. It also exists in the middle. It allows you to do things like templating. And so let's just do this up the top here. And again, in Q, you can have schema and data co-located in the same files. So here, this is the configuration file. Just as a reminder, we are loading as part of our program. It's effectively our test. So let's try and dry up this configuration file. So again, we're going to use a pattern constraint. We're basically saying for any program configuration that we want to declare, and that's that pattern constraint again, the string in square brackets, the following constraints will apply. And Q is constraint-based, but it also allows you to template things as well. So let's do one thing. Let's just say, because we want to use the name of the program that we are configuring here as part of these constraints here. So for path, what we're going to say is that there should be a default value of path2, and here we're going to use string interpolation, and this is, I believe, inspired by Swift with the backslash and then the parentheses name. And to complete the default, we just say, this is a disjunction here with a bar. We won't go into the details of that now, but the use of this star here with a disjunction just allows me to specify a default. And anyone who's interested, please feel free to come and chat to me at the end about this. But this is me saying, if there is not a path field specified for a program's configuration, then use this value here. And this value here is path2, and then we use string interpolation to say, take the value of the variable name. So let's just do a bit more drying up here. So for starters, let's just delete all of these because they all follow this pattern. Great. Okay, what else is going on here? Well, looks like directory. Yeah, so maybe we need a default value for directory again. So let's do that here as well. Excuse me, wrong way around. /home cuckoo. Just complete the default in that situation. And looks like we're fairly consistently having descriptions start with the name of the program that we're configuring as well. So let's also constrain that. So we're going to say that as a description, and for people who are familiar with the strings package in Go, Q has a very similar set of built-ins as part of its standard library. So what do we want? We want strings to have prefix, and we want to use the name variable here, which is the name of the program that we're actually configuring. So let's just import strings up the top here. What else can we delete? Well, directory here is not the default, so we need to leave that one in place there. We can delete it from there, and we can delete it from there as well. Okay, so that's nice. So service 3 is very much slimmed down now. We'll see the results of this in a second. You can see how this templating is helping us to dry up our configuration as well, by extracting those common pieces, specifying them in a more of a sort of a generic way, and then we'll see Q come to life in a second when it actually applies those templates to things. Looks like args is the same here between service 1 and service 2. Let's just do something a bit fun here and say, the args for service 2 is service1.args. And so that then constrains those two to be the same. So here you've got references that in YAML there is some support for references, but in Go obviously we have the concept of references because that's what variables fundamentally are. They allow you to refer to different things. So here this is constraining that service2.args is the same value, whatever that value is, as service1.args. And let's just assume we have that as a constraint in the system. Okay, hopefully I haven't made any typos here. So now when I do go run dot, great. So you can see, let's just take a look first of all at service 3. The directory is in there. The description, well, that was only a constraint. That was only required that it start with service 3. The path follows that pattern again. So you can see how these up at the top here, these templates have allowed us to dry up that part of the configuration for the specific programs themselves in this sort of cross-cutting way, say, well, these defaults apply to all programs that we're configuring. So that's kind of nice. So it's in this situation here, you can see how, as the user, we've specified some defaults here. And this is what we've done, is we said in our configuration, if the path field is not specified, then it should default to this value here. But as the program, it's also useful to be able to specify default values if the user hasn't provided something. Because it's a bit of a burden for the user to have to specify default values for all fields that might need to be configured. Everybody uses tools that have sensible defaults. Let's just call those program defaults and look at how they would work in this situation. So let's just go back to here, and we're going to create ourselves defaults.q. And again, we're just going to put some package main for now. And again, what we're going to do is we're going to specify a pattern constraint here. So again, this is saying for all program configurations that are declared, let's just specify that the retries field that we haven't seen yet should have a default of 3 if that field is not specified. That's really fun. And again, what you can see here, this is a nice syntax feature of Q here. I'm not having to use curly braces. This is like a shorthand way of saying, if I was to put it in the longhand form, you could sort of see how all these braces start to become a bit burdensome. But we can align those braces with Q, and that gives us a much shorter form of declaration saying here for the retries field, it should default to 3. So now let's actually update the main.go. So this is the third argument that we pass to qconfig.load. And in the same way that we embedded the schema, what we're going to do is we're going to embed, if I can type, defaults.q, and we're going to call this defaults. And again, it's going to be byte slice. And then we just pass the defaults here. Let's clear this, run again. Great. So now you can see the retries field for each of these services, because none of them actually specifies a value for retries, and so that default applies. But that's a default that the program has specified in that situation. So the user defaults have already been applied, and then we said, well, let's now apply the program level defaults for those fields that haven't specified, and that's where we find ourselves right now. So that's also very good too. So this is all fine, but sometimes you actually want to be able to have at runtime values that, for example, from your environment, that get blended in with the configuration that you're loading as well. And this is where the final parameter here, the qconfig.load, comes in, and that's a value that we can specify for runtime values. So what we're going to do here is this is a tiny bit of a sort of hacky way to do it, but it kind of works. Is we're going to say that this variable r is a map from string to any, and within that we're going to just say, well, we're going to specify a runtime field, and that should be a map from string to any, and then within that we're going to say working directory should be /runtime blah, and just add the comments where we need them there, and then we're going to pass that runtime value there. So here I've clearly hard-coded the working directory, but you can imagine this sort of being taken from your environment or something like So squint your eyes enough and you can sort of have a bit of creativity as to where that runtime value might actually have come from. It doesn't actually matter. I've hard-coded it for now. So now what we need to do is just update schema.q to say, well, in addition to the programs that we will declare, the configuration for our programs, we're also going to allow some sort of runtime configuration as well, and we'll declare ourselves a definition to describe the shape of that. And as you saw, we had working directory, and we're going to allow that to be type string. So this allows us at runtime to say, well, I'm going to mix in effectively some runtime configuration, and this is the shape of that runtime configuration that I'm going to pass in. And so you can see that follows the shape of the value that we've effectively just created ourselves here. The runtime field and then the working directory field. So that qconfig.load will actually blend those two things together. So then all we need to do is actually use this within our config as well. So we're just going to say, well, there's now a runtime field and that has some value associated with it. Let's actually move that from the bottom up to the top because I want to use it here. And we're going to use it for the directory, won't we? So we will say runtime.working directory. And if I've done this correctly, we should now see the directory field for these services be updated. Have I done it correctly? Yes, fantastic. So runtime blah. So there you see we've combined not only the user configuration, the program defaults, plus some runtime values, wherever they may have come from, into our resulting configuration. So now, if our program actually did something useful, it would have combined, as I said, those three things: user configuration, which may have some defaults as part of it, program level defaults, plus some runtime values as well. And that all happens, as you saw within, let's just go back to it, this single call to qconfig.load. So that's how easy it is to take the JSON configuration, convert it to Q, and then use qconfig.load with these different layers to actually then drive your configuration. Let's check. Something else? Oh. Great, back to the slides. We've done all of this. Great, so what have we seen today? As I said, we've now seen how Q can be used as a configuration format for a Go program. And the main question you might be asking is, well, why would you use Q? Well, hopefully you saw some aspects of the Q language that lend themselves much better to maintenance of configuration files. So configuration files are not always as short as you just saw for that JSON file there. They can be much, much bigger. And if you have large production services, YAML, Kubernetes, it can get incredibly unmanageable. And if you're trying to edit those YAML files and actually maintain them with lots of redundancy and repetition between them, it can get very burdensome. Hopefully you've had a bit of a sneak peek as to how Q can help you reduce that redundancy with the type safety and the validation that comes with Q as well, allowing you to then template out your configurations and just make your lives a whole load easier from like a maintenance perspective. And that maintenance is key because configuration files actually drive production systems. And so getting those changes right is important. Being able to validate those things ahead of time as well is also critical because it saves you just trying to make a change in production and it not work because you had a field that's meant to be string actually be an integer. Q allows you to catch all these things early. And as we saw today, qconfig is an experimental package that allows you to take an existing Go program, and easily load JSON or YAML configuration as part of that. We also saw the Q command line interface as well. And you implicitly saw us as well using the Q Go API. It was sort of hidden away behind the qconfig package. And if the qconfig package actually graduates out of being experimental, then you'll see that you're actually using the Go API for Q as well. So Q has got lots of different facets. So what is there still to come? This is not just it for Q. We don't yet have full support in modules in Q, so much like in Go, when you can do Go gets to remotely fetch modules and add dependencies to your program, you can't yet do that in Q. But as you've seen, we have the concept of packages. We're hoping to finalize the second part of the modules proposal very soon and share that, as well as actually creating an initial version of language server protocol implementation. So for those of you familiar with using VS Code or indeed any editor, and typing within your editor and getting things like code completion, error reports, etc. That comes from a tool called the LSP, or the Language Server Protocol, and the Go implementation is called Go Please. The Q version will be called Q Please, and that will give you that ability within your editor, editing config files, to have things like code completion, error handling, automatic formatting as you saw. So that same rich experience you have with editing Go, you will also have for Q as well. We also want to support more data formats. As you saw, we imported and exported JSON. We can also handle YAML, but we want to extend to languages like TOML as well, and indeed any others you might want to. But Q also understands how it can import and export between things like JSON schema and actual Go code as well. So please let us know if there are data or schema representations you want us to support. That is it. Thank you very much.